So, hello everyone. We'll wait for 5 minutes to let other people join and then we'll begin with the session. Okay, so we shall begin now. Hello everyone. A very warm welcome to all of you. Thank you for joining us today for the exciting webinar on Data Analytics Masterclass, which is on SQL for Data Analytics. So in this session, you will learn about how to transform raw data into actionable insights using SQL, the most essential skill for every data analyst, right? We will explore real-world query writing, data cleaning, using data analytics, we'll explore real world query and using SQL joins aggregations, window functions, and how SQL powers dashboards, business decision making across industries. Okay, so let's now move on to our expert speaker for today. The webinar will be presented by Mr. Devendra Kumar Sir, Senior Data Analyst with over 8 years of experience in data analytics, machine learning, business intelligence, and stakeholder management. He's also an experienced trainer specializing in AI, ML, and generative AI, helping learners bridging the gap between theory and real world application. This session is brought to you by the IoT Academy and EdTech Training, partnered by Uniconverse Technologies, which is our parental company. Founded in 2017, based in Noida, India, the IoT Academy offers you industry-focused certification courses like the IoT, embedded system, artificial intelligence, machine learning, data science, Python, digital marketing, both online and offline. The Academy collaborates with top institutes such as IIT Kanpur, IIT Roorkee, IIT Guwahati, emphasizing hands-on learning, experience, career support, and real-world projects through its parental company, which is Uniconverse Technologies. So we are thrilled to have you all here. So without any further ado, let's dive in and explore how you can build a successful career in data analytics, right? So the topics for today's session are query fundamentals, advanced joins, aggregations and analytics, window functions, subfunctions and CTEs, performance optimization. So I would like to hand over to our speaker for today, which is Devendra, sir. Over to you, sir.
Good evening, everyone. Resham, am I audible?
Yes, sir, you are audible.
Oh, oh. Today we will see this important topic, which is SQL for data analysis. Okay, and in this session we will use cricket dataset. Okay, so our agenda here is the introduction to the cricket dataset. First one. After that, schema and ER diagram. Okay, query fundamentals, joins and relational analysis. Okay. Aggregations, window functions, CTEs, and after that's performance and best practices. So let's explore the data set. This training uses a cricket.db SQLite database. Okay, and we have here 5 tables. So these are the table names: teams, players, matches, match scorecard, and ball by ball. Okay, we are using SQLite database, and we have 5 tables. And this is the table overview. We have teams table first. And in teams table we have these columns: team ID. Okay, so it's a unique identifier to identify a particular team. For example, team ID 1 for India, team ID 2 for Australia, etc. Okay, team name. Okay, team coach, captain, ICC rank. Okay, so there are 5 columns in this table, teams table. So let's explore this table. I'm choosing file DB, cricket DB. And here we can see schema, right? These are the different tables, right? And the schema, create table. So we have our first table is teams table. So I'm writing select all column from teams and running. So we have team ID, right? Team name, coach, captain, and ICC rank. Okay. So select is the command used to fetch the data, and this star is used for all. Select all from table name. Okay. So next we have players table, and we have player ID, player name. Okay, country, team ID, matches, runs, wickets, strike rate, average, hundreds, 50s. So let's explore this one also. Again, I'm selecting from this time from different table. Select from players. And here you can see the data. Okay, all the columns with data. So Virat Kohli, okay, player name, player ID is the one, player name, country, okay, team ID, matches, runs, wickets, strike rate. So it's a dummy data, okay. It's strike rate, average, hundreds, fifties. Similarly, other players. And third table is the matches table. Here we have different columns, match ID. Okay, it's a primary key for this table. PK is primary key. Team 1 ID underscore ID, team 2 underscore ID. Okay, because it's a match table. So it means there will be two teams. Okay, so that's what it's team ID 1, team 1 ID, and team 2 ID. Venue, okay, match date, winner team ID, man of the match. So we can also select from this to see the data. So select all column from matches table. So here we have the data. Next, match scorecard, and here we have different columns. Match scorecard ID, the primary key for this table. Match ID, team ID, runs, wickets, overs. So quickly see this one as well. And this is the result. Scorecard ID, match ID, okay, team ID, runs, wickets, overs. And the last one is the ball by ball. So ball by ball table, and we have these columns: ball ID, match ID underscore ID, over ball, batsman, bowler, runs, off bat, extras, dismissal type. So ball by ball, we'll select from ball by ball. So here we have the data. So it's a ball by ball data. So it's a ball ID, okay, the match ID, and there's first over, and the first ball. Okay, I'm using the dummy data. I'm not using the complete data. So here, that's why we are just getting only, you can say, 3 balls from first over. But we know there are 6 balls, right, in over. But I'm just showing you a small data set. Okay, so first over, ball 1, the batsman, okay, 1, bowler runs off the bat 0, and from the second, and in the second ball it's a 4. Okay, batsman goes for 4. Okay, then 6. Okay, no extras. And here in the here it's over second over, third ball, it's caught. Okay, out. So now we have all these tables. Let's, so this is the in relation between the table, right? So team ID, okay, team name. Team ID is used as a primary key in the teams table. It's a uniquely identifying the records. Okay, primary key, PK. And in players table, player ID is the unique key, it's primary key, and team ID is the foreign key. Because why is team ID is a foreign key? Because team ID links teams table. Okay, so teams table is linked through team ID. So that's what's a foreign key. So in order to get from data from both the tables, we need to use this common call, team ID. Similarly for others. So now start our fundamentals, query fundamentals. So these are the basics of data extraction using select and where clauses. Okay. For example, I need to select from the players table. Let's say we want to select. Initially, we are selecting all the columns. That's why I was using star asterisk sign, right? But you can select particular column as well. So you have to mention the name. Okay. So select player ID, player name, country, runs, wickets from players. So we are using this query here. So this query, this one, not let me remove this query, this one. Okay. Select player ID. It means select is the keyword. Okay. So one important thing is that SQL is case insensitive. Okay. So you can write select in capital letter as well as in small letter. Okay. It will not affect the result. Okay. It will execute. Okay. Similarly, all these things. Select player ID. So I'm selecting player ID column, player name column, country, runs, and wickets from players. And I'm also giving the condition. Only select those players from the player table where they have scored runs more than 5,000. So where is the clause? Where is giving you the condition? So first remove this where and just run and see. We are getting this. This is our result. Okay. We have selected player ID. It's a player ID, then player name. Same sequence. Player ID, player name, country, runs, and wickets. We have selected 5 columns. Okay. From players. And how many rows? 6 rows. Okay. But when I include where clause here, where runs is greater than 5,000, only select those rows where runs scored is greater than 5,000. And order by is another one where I'll arrange the data in decreasing order. First, I'll get the data of that particular player who have scored highest runs. Okay. So if I do this thing greater than 5,000, I'll get this first row Virat Kohli because scored 13,000. Okay, it's greater than 5,000. I also get this Rohit Sharma, second one, but I will not get this Pat Cummins. Okay, 1,200 because it is less than 5,000. So this condition checks. Okay, and checks because here we are saying where runs, right? So this column where clause is checking this one. So this column will not be this row will not fetched by the system. Okay. David Warner will get David Warner. Okay. We will not get Ben Stokes because it's saying greater than. It's not saying greater than or equal to. And here in Ben Stokes we have exactly 5,000. If I do this greater than or equal to, then Ben Stokes will also come in our data. Okay. And Kane Williamson we also get. So how many rows we'll get? We'll get Virat Kohli, Rohit Sharma second, 3 and 4. 1, 2, 3, and 4. Okay. We will not get this 1,200 and this 5,000. And let's run this. See. Okay. So Virat Kohli, Rohit Sharma, Kane Williamson, and David Warner. Okay. And descending order as well. Okay. First, we'll get the data of Virat Kohli because scored the highest run. Then 10,500. Rohit Sharma. Then descending order. Then 7,000. Then David Warner. Okay. If I don't use this DESC keyword, DEC stand for descending order. If I don't use this descending and only do order by runs, then it will automatically do the ascending arrangement. Okay. See, by default, if I'm not using the descending keyword, so it's giving the data in ascending order. Again, the same data, but in ascending order. So David Warner comes first, okay, 6,500. Then 7,000, Kane Williamson. Then Rohit Sharma, 10,500. After that, Virat Kohli. Okay. So the select, from, where, order by, these are the keywords. DESC. And this is our table, and these are the columns. Okay. Next. Filtering and sorting. In filtering and sorting, we are doing filtering, okay, as well as sorting. So if we run this one, okay, top 10 run scorers. So we are selecting player name and runs from players order by runs, okay, and we are limiting by 10. We run. We are getting 1, 2, 3, 4, 5, 6, 7. Why 1, 2, 3, 4, 5, 6? Because we have only 6 players in our data set. So that's why its limit will not work at 10, because we have to arrange. Let's go for, we have 6. Okay, let's go for top 3. Top 3 run scorers. Okay, so we are selecting player name runs from players table. We are order buying. We are doing ordering through runs column and in the descending order. Okay, and we are in through limit. We are saying just give me the data of first 3 rows. Okay, top 3 run scorers. So this is our data. It's Virat Kohli, Rohit Sharma, and Kane Williamson. Okay, so here we are doing filtering and sorting. Filtering. Okay, next, joins. So joins are used to connect more than one table. Okay, 2 or more than 2 tables. So we are selecting, again, select t dot player name underscore name, t dot team underscore name, t dot runs from player. So here we have 2 tables. Okay, initially we are doing only for 1 table. Okay, so here we have 2 tables, players and teams. So I'm selecting player name and runs from player table and team name from the teams table, and I'm using this p so that it's act as an alias. Okay, so I'm saying players table is, we are naming it as p, and we are naming teams table as t. Okay, and we are saying get these columns from these 2 tables and join where team id is equal to team id from the players table is equal to team id from the teams table. Okay, so joining on common data, common columns. When you run this, see, now you are getting player name, team name, and runs. So player name and runs are coming from the players table, and team name coming from the teams table. So you are joining, okay, 2 tables. So player name, team name, and the runs. Okay. So join is the keyword here, and we are saying join. This is the inner join. Okay, it means if the player name is available in the players table as well as in the teams table, then it will fetch the data. Okay, so here we have joined two tables. Okay, columns, and getting columns from these two tables. Joins matches with teams. Now in the previous ones, inner join, here again inner join, but we are saying matches with teams. Okay, so we are joining different tables here. Okay, so we are saying select m dot match id. So this is coming from the, here we have two tables, matches m, okay, and teams table, different teams, team 1, team 2. So m dot match id, t1 dot team name as team 1, okay, t2 dot team name as team 2, m dot venue is coming from the match table, m dot match date again coming from the matches table, and from matches m, and we are joining teams t1, okay, where the team 1 id is equal to the id, team 1 id in matches table matches with the team id in the teams table. Okay, if you run this now, here see we are getting match id, team 1 name, team 2 name. So match id 1, team 1 is India, team 2 is Australia, and venue, location is Mumbai, and the match date. So with the help of joins, now you are connecting different tables, right? England, New Zealand, the venue is London. Okay, match date is this. So when you see any match and use, we always see this kind of data, right? So it's coming from this in this way. Okay, different, we have different tables, and now it's getting from different tables like this one. Okay, left joins and missing data. So where here we have different kinds of joins. What we did previously is the inner join. Okay, and here we have left join. Let me, so what left join is doing is it's selecting all the rows from the first table or from the left table as well as the common one. So if I run this, so we have team name from the teams table and player name from the players table. Okay, from teams T, we are joining, left joining players. Okay, T dot team ID is equal to P dot team ID. So running this, we are getting team name, player name. Okay, and it's India, India. Okay, Virat Kohli, Rohit Sharma, Virat Kohli, Australia, David Warner, Pat Cummins. Okay. And this England, Ben Stokes, New Zealand. If I do P dot team ID is equal to T dot team ID, wait. Okay, so here again we are fetching from these two tables. Next is the aggregation group by. Aggregations means we are combining, we are aggregating, okay, we are summing. So let's say we want to know the total runs per team, okay, total runs per team. So let's say in any series we have different matches. A particular team plays different matches, right? Multiple matches. So in order to calculate the total runs per team, we have to add, right? So here aggregations come group by. So total runs per team. So we are doing select t dot team name. We are selecting team name from the teams table. This sum we are summing runs from the players table, and we are aliasing it. We are saying it's this call. This will be the column name. Okay, summing all the runs. We are saying it's a team runs from players P. Okay, and we are joining teams. We are joining teams on t dot team id is equal to t dot team id. Team id from the players is equal to team id from the teams. And here we are grouping by the team name. We want the data by the team name. Okay, the grouping. Okay, we are aggregating as well as grouping. Okay, right, and order by team name runs. It means the team who scored total runs, highest total runs will be on the top. Okay, in the descending order. If we run this, you will get this. So team name India, total runs, team runs. Okay, then Australia, then New Zealand, then England in the descending order. So we are summing. Okay, so we have these two tables, team and players table. So in players we have runs. Okay, in players table I have already shown you, right? In players table we have runs, so we have to sum up. Okay, and we are grouping by so that we'll get the result based on the team name. Okay, so group by team name. So what group by will do, it will see the row where India is there and it will sum up where the India is present. Okay, and add all the runs and it will show like this. Okay, and again it will go to these two tables. We'll see where's the Australia, sum up all the runs and it will show like this. Okay, next, having is used to filter groups. So understand in this way, team with more than 15,000 total runs. So we are doing team, we are selecting team name from the teams table, t dot team name. We are again summing up runs because it demands total runs, right? We have to calculate, aggregate. And we are saying call this total runs as team runs. From players P, we have two tables here, right? Players and teams. And we are joining on team ID, okay? Because we know we have in teams table, we have team ID, right? And in players table, we also have team ID, okay? So join on these two common columns. And we are grouping similar to our previous result. But here we are only, see in the previous one, we are getting the data of total team runs. We are not giving any condition, but having is used to provide us condition. Okay, we can filter further. Okay, so like in this we are getting 4 rows, but here we are saying having some p runs, total runs must be greater than 15,000. So in the previous one we are getting 4 rows, but after using having, we will only get how many rows where the total runs is greater than 15,000. So we'll get India because greater than 15,000. We'll only get India. Okay, right? So if you run, query is like provide me all the runs where provide me all the teams where they have scored total runs in the series, okay, and more than 15,000 total runs in the series, okay. So you'll get India. Next, window functions, okay. So window functions are used for ranking and other tasks, okay. So let's understand. We are ranking players by runs, okay. So if any player scored higher than other, it will rank higher, okay? So select player name and runs. We are selecting two columns, and this is the keyword, the rank window function. Over, we are saying the rank over this runs. Create the ranking of these players, and what will be the criteria of ranking runs, right? Okay. And in the descending order, it means the player who scored highest will be on the top. And call this all as run underscore rank, okay, this column. And we are selecting only here we are selecting only from the single from a single table. It's a players table. If we run, see Virat Kohli, the highest 13,000 runs. It's a, okay, rank one. Rohit Sharma, it's 10,000, second rank. Okay, Kane Williamson, third. So here we are ranking based on the runs. Okay, fourth, right, sixth. Then Ben Stokes, then Pat Cummins. So based on the runs. So window function is used to rank players based on their runs. And other criteria. Here we have runs. For bowlers, we can go for number of wickets taken, right? Okay. And window function, here we are using for ranking. We can also use for partition. So rank players within each team. In the previous case, we are ranking player wise. Okay, we are not ranking team wise. So in the previous case, we are ranking Virat Kohli as the top because he scored the highest one, and Rohit Sharma second. But when it's partition, we are saying rank within each team. Okay. So if we run this, we are saying select player dot same p dot player name. We are selecting the player name. After player name, we are selecting team name from the teams table, then runs from the players table, and we are ranking over. We are ranking over, and here we have another keyword partition by. So here we are saying partition. Use the partition based on the team name, and create the ranking. Okay, partition by team ID or team name. Okay, and here we are joining two tables. Okay, players as well as team. If we run this, see now the difference from the in the previous and this one is Virat Kohli is the first and Rohit Sharma is the second. But after this, David Warner is not the third one. It's the again first because it's ranking only within the team. Okay. So here we know very well we have team ranking as well as overall ranking of a player, right? So team ranking is useful when coach wants to select the particular right. You can say the number of players. Okay. To you can say that to make 11 players within in a team. So team ranking is useful in those scenarios. Okay. So here Virat Kohli and Rohit Sharma because they are from India. So here ranking team one and it's 1 and 2, and David Warner and Pat Cummins, Australia. So in Australia, the Australia teams, first is the David Warner and then Pat Cummins. And England, as we have only England, only one row for England and New Zealand, we are getting 1-1. Okay. So it's a team ranking. Okay. So we can create team ranking based on partition. Next, we have scalar subqueries. And here, players above average runs. Select all the players who have scored above average runs. Okay. So we are saying select player name runs from players where condition, we are giving condition where runs greater than the average from all the players. So select only those players who who are above the average. So for example, we have, let's say, 3 players. For example, we have 3 players who have scored, let's say, 100, 200, and 300. Okay. So what will be the average of these 3 players? 100 plus 200 plus 300 divided by 3. So it will be 600 divided by 3. So average is 200. So if I say select only those players who have scored more than 150. So we will select only 2 players who have scored more than 250. Okay. Who have scored more than 150. So player who have scored 200 and the player who have scored 300, because their runs are greater than the it's 100 200, they are greater than the 200. So if I say select only those players who have scored more than average, so here we have the average 200. So we'll get only the first player, only that player who have scored 300. Okay, because it's greater than the average. So similarly here, so Virat Kohli and Rohit Sharma are the only players who have scored, who have more than the average of all the players. Okay. So this is the scalar subquery. Scalar, because we are subquery means we are running query within query. Okay. Here we have the main query. It's right, this one, and here is the subquery, because we are running again select within the query. Okay. We are saying select player name and runs from players where runs are greater than average runs from all the players. Okay. Next, we have CT common table expression. It's used to write complex logic. So it starts with. Okay. So here we are creating a table, top players from this query. We are selecting player ID, player name, runs. Okay. Row number is the sequencing 1, 2. Okay. Based on the runs. We are creating ranking based on the runs. Okay. So this is the first table with the help of CTE. And now we are selecting from this top player. We have created top players underscore players as our table. We know we have 5 tables, right, in our database. But with the help of CTE, you are creating tables, temporary tables, okay, for the query. Okay. From this table, it's players table, we created our top players table, okay, underscore players. It will help us to now select from this table. Okay. Now we are saying select all columns from top players where rank is greater than less than or equal to 5. So if I run this, if we will run, okay, less than or equal to 5 here, or less than equal, let's say do less than or equal to 3. So we'll get only these 3. Okay. So with the help of CTE, we can write complex logic, okay? Because we have created first the table top players from this table, players table. Now it's easy, okay? It is acting as a table, okay? Top players like other 5 tables, okay? And from this, we are selecting where rank is less than or equal to 3. Let's clear this. Ball by ball analysis we can do. Select match ID, player name, runs off bat from balls by balls. There are 2 tables, okay? Balls by balls, players table. So if you run, you are getting the match ID, the name of the batsman. Match ID is the unique match name, we can say that, okay? And the batsman. So for the match, this match ID, batsman Virat Kohli runs off bat 6, okay? Rohit Sharma 6, okay? Because we are saying where runs is equal to 6, okay? So we're getting these runs. Compute cumulative runs. We can also compute cumulatives. So we are using this one from ball by ball, okay? Cumulative means match ID first, batsman 1, uniquely identifying, cumulative 0. Then the same match, okay? Now batsman scored 4. Then he scored 6, that's why it's 10. Okay, so this is the cumulative we are adding, okay? So it means batsman 1 scored 10 in match 1, okay? Similarly, now match ID same match, second batsman first scored the first 1 run, then it's a dot ball, that's why it's 1, okay? And again it's a dot ball, that's why it's a 1, okay? Similarly, now the next match, second match, okay? Batsman, sixth batsman scored 2, okay? So we can also do cumulative analysis. Match summary scorecards, okay? And these are useful, okay, after the match. So we are, after running the query, we are getting match ID first in the this match, team name is India, runs 320, wickets 6 wickets and 50 overs. Same match, Australia 280, 10 wickets and 48.2 overs. Okay, so this is the match summary, right? Okay. So we can also do this. Where match, okay? So that's a match occurred, okay? So match summary is like this. Particular match, teams India scored 320, 6 wickets, okay? 50 overs. And Australia scored 280, lost all the wickets. So it means India is the winner here, okay? Winner count we can also do. let's say from the table series, India won 2, New Zealand 1. And now we have these use cases: top performance dashboard, right? Combine aggregations, window function, right? And joins to build leaderboards and trend charts for comprehensive cricket analytics. So whatever I'm showing you, these are these things used in the cricket world, okay? As cricket analyst, you have heard about this thing, right? So this is the advanced query example. Top batsman per team. How to know top batsman per team? So it's a per team, okay? So team wise. So you'll only get one batsman, okay, per team. So we are saying team name, select team name, player name, and runs from. Again, we are selecting here team name, player name, runs, and the row number is used to create the ranking, okay, partitioning and ranking. And we are using partition as I previously showed you, right? So partitioning means we are creating ranking based on team, okay, team ranking, okay. And in the last we are saying where rank is equal to 1, because in the previous cases we got all the ranks, right? 1, 2. So only because we are looking for only top batsman here, okay. So we'll get top from India, it's Virat Kohli, Australia, and the ranking is based on the runs, okay. England and this New Zealand, Kane Williamson. So we can also go for data quality checks for nulls in foreign keys, okay. Identify unexpected duplicates, okay, and detect outliers in numeric fields, runs, overs, okay. So let's say one of the tables over is greater than, let's say 50, let's say 100, okay, and we know there is no such format, okay, for a single team. For a team it's only 50 over match, okay. So that this run is the outlier, okay, 100, oh sorry, over, this over. Or say runs comes in the field, let's say runs is let's 10,000 runs, okay. And again it's an outlier, it's an anomaly. So we should check for these through SQL. So this is the practical exercise which we can do. It's find players who have hit more than 50 sixes using ball by ball data aggregated by batsmen. So you need to find the player who have hit more than 50 sixes. But in our data, we have very small data. We can go for, let's say, 1 6. Okay, but logic will be the same. So I have this query here. So let's say we are saying greater than or equal to 1. Because I'm showing a very small data set, logic will be the same, okay. It's up to the demand, okay, what you are going to you can say less than, let's say greater than 10 or 50, any number. So I'm saying greater than 1. So in our data set we have only 2 players, okay, who have scored 1 6, okay, total sixes. Next we have compute the strike rate per player from ball by ball, requiring calculating runs and balls faced, okay, right. And we have also seen this thing, right? In the current live match we see this thing, right? Strike rate is coming instantly, right? So it comes through these queries, right? These queries in the backend, okay. So compute the strike rate per player from ball by ball, okay. So we know strike rate is the formula of strike rate is total runs divided by the total balls faced. So let's say a player faced 6 balls, and he scored 12 runs. So 12 divided by 6 is 2, and you have to multiply this as well. Okay, total runs divided by total balls faced into 100. Okay, so 12 divided by 6 into 100 will be 200. Okay, so we have this query as here. If we run this, it's like it's a, right, runs off the bat into 100 divided by the balls faced. Okay, so players, player named Virat Kohli, 3 ball faced. Okay, total runs 10. So 10 divided by 3 into 100 will be 333.33. Kane Williamson, 1 ball faced. So 2 divided by 1 into 100 is 200. And 7 divided by 4 into 100 will be 175. Okay. And again, another create a leaderboard for most consistent batsman using standard deviation. Again, variance of score per match. So we can export query results here, right? Like this one. We can export, we can download. Okay. And you can this one. So after getting this, you want to, let's say you want to create visualization chart and all, you can download and open the Excel and do further visualization. Okay. And you can load this data after getting from the SQL. You can load this data and this CSV which I have downloaded, Power BI table as well. Okay. And for other feature engineering tasks, machine learning. So here we are using SQLite, SQLite.js playground. Okay, we have loaded cricket database, and you can build dashboard through SQL. Okay, by first fetching the data and then dumping that data into Excel or visualization, data visualization tool. These are the resources. And guys, before leaving, before asking any questions, we have this feedback form. Okay, where you have to share these details. Okay, what's your current status, what's your highest qualification, and any suggestion, and which self-paced you would you like to enroll. Okay, and what is your you can say that opinion about the upcoming master classes, what topics would you like to see covered in the future sessions. Okay, so please fill out this form, and after that I'll ask question, we'll take your questions. Please copy this link. Okay, save this link, just click and it will open. Okay, and fill out all these details. Okay, it will help us to create more useful master classes. Okay, Okay, didn't get the link. Let me paste the link here. Please open your Q&A tab, and I have pasted the link. Click the link and fill out all the details. And meanwhile, you can type your question as well. You can type your questions. We will take Q&A regarding the SQL. Okay. What questions do you have for me regarding SQL? You can type the Q&A chat box in the Q&A section. Participants, please type your question. What questions do you have for me regarding this session, SQL? Okay. Fill out the form, feedback form, so that you can receive your e-certificate. Okay. And we will create different master classes, different topics. So you can suggest through our feedback form. Okay. And after filling out the form, you will get your e-certificate. Okay. So thank you so much for joining. Now we are closing. Thank you.